We will be studying binomial theorem. The way we're going to approach this is we're going to review the concept of combinations. We're going to try to understand what a binomial is. We're going to examine the binomial theorem formula, and then we're going to apply it. So combination is expressed in this form. You have this form here, or you can have the C form. And what you want to remember with the binomial, to understand binomials though, you have to go review factorials. Let me take a quick second to review factorials. So if I have something like a 3 factorial, all we're trying to do is we're going to multiply 3 by the consecutive numbers, decreasing consecutive numbers until we get to 1. So 3 factorial is going to be 6. So this is what you do with factorials. I'm going through it so you can understand it because we're going to need it for the rest of this topic. So with combinations, if you have a situation where you're looking for, let's assume it's 7 combination 3. I like this format, it's fine. You can also use 7 combination 3, whichever one you prefer. So what you're going to do is you're going to find, if you look at this as the number on the top and the number on the bottom, you're going to find the value of 7 factorial, and then you divide that by the value of 3 factorial, and then 7 minus 3 factorial. So this is what you do with combinations. Now let's try an example. So what is the value of C52? So I'm going to write it in this format so that it's easy to see what we're trying to do. So this is going to give us 5 factorial divided by 2 factorial multiplied by 5 minus 2 factorial. So this is going to give us 5 factorial divided by 2 factorial multiplied by 3 factorial. So generally the way I like to go about this is 5. I keep reducing until I get to the highest factorial in the denominator. So 5 multiplied by 4 multiplied by 3 factorial divided by 2 multiplied by 1 times 3 factorial. So this is going to cross out. And then we have 5 times 4 divided by 2. We can cross this out. 5 multiplied by 2 is 10. Now, let's look at binomials. A binomial is simply an algebraic expression with 2 terms. So, generally with our binomials in this lesson, we're going to focus on mostly linear binomials. So you can see that each of the terms here is a linear term, and you have 2 terms in the expression. So the binomial theorem explains how to raise a binomial to a non-negative number, so just to a positive number. And according to the binomial theorem, when you are trying to expand, here's an important thing to note. You notice here, if you have x plus y to the power of n, you start with n0 until you get to nn, and you want to first the x value, or the value right here on the left hand side of the binomial, you always raise it to the highest exponent, and your value on the right of the binomial, you always start with the 0 exponent. One of the things you have to pay close attention to is that the sum of your exponents must always be n. So you have n minus 0 plus 0, that's going to give you n. And as you go through here, you want to pay attention to the fact that the sum of the exponents of your terms must always be equal to n. Let's look at some examples. What is the coefficient of b to the 3rd power in a plus b to the 6th power? So what I know here, because the sum of my exponents must always be equal to the value of n, which here is 6, I know that I have a to the third power, b to the third power. So I don't know what the coefficients of these terms, will be, but this gives me a starting point. So this is going to tell me that I'm going to have 6, 3, okay? Because remember that the exponent of b is going to be the lower number here. So 6 to the third power, then we have a to the third power, and then b to the third power. So now let's go ahead and find the value of 6 combination 3. So this is going to give us 6 factorial divided by 3 factorial, and then 3 times 2 times 1, which is going to give us 6 times 5 times 4 times 3 factorial divided by 3 factorial, and then 3 times 2 times 1 is 6. So we cross out 3 factorial, and then we can cross out 6. So this is going to give us 6 is, we have 5 multiplied by 4, which is going to give us 20. So with that term here with the coefficient b cubed is going to be 20a cubed b cubed. So the coefficient of b cubed in the expression is going to be 20. Now we're going to use the binomial theorem to simplify x plus 2 to the power of 4. Now let's go ahead and start it the way that I recommend every student start this kind of question. So we have x plus 2 to the power of 4. So this is going to give us 4, 0. Then you have x, 4. Then 2 to the power of 0 plus 4, 1. We have x to the power of 3, and then 2 to the power of 1 plus 4, 2, x to the power of 2, 2 to the power of 2, plus 4, 3, x to the power of 1, 2 to the power of 3, and then plus 4, 4, x to the power of 0, 2 to the power of 4. And I want you to notice a trend, very important trend. You notice here that the exponent of x is always going to be a subtraction here, 4 minus 0. And then the exponent of y is going to be the value of the bottom number in the combination. And then an interesting way to know if you're doing it the right way is you got to add the exponents, make sure it's always the same as your value given. So 4 plus 0, 4, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, 0 plus 4, 4. So now what we're going to go about doing now is to find out the value of this combination. So for 0, let's do some work here. 4, 0 is going to be 4 factorial divided by 0 factorial, and then 4 minus 0 is 4 factorial. This is going to give me 1. 4, 1 is going to give me 4 factorial divided by 1 factorial. 4 minus 1 is 3 factorial. 1 factorial is 1, so I'm just going to ignore it. So it's going to give me 4 times 3 factorial over 3 factorial. So 4, 2 That's going to give me 4 factorial divided by 2 factorial, 2 factorial, which is 4 times 3 times 2 factorial divided by 2 factorial times 2. So this is going to give you 6. And then 4 3 is going to give us 4 factorial divided by 3 factorial, 1 factorial. So that's going to give us 4. Okay, so now we're going to apply this here. It's going to give us 4 factorial is 1. 4 combination 0 is 1. So that is 1 x to the power of 4. To the power of 0 is 1, so we ignore it. Plus 4 1 is going to give us 4. Because don't forget here, crossing this out. So 4, and then here we have x to the 3rd power multiplied by 2. Then we have plus 4 factorial 2 is going to give us 6. We have x to the 2nd power, and then 2 to the 2nd power is 4. Plus 4 factorial 3, that's going to give us 4. X to the 1st power, and then 2 to the 3rd power is going to give us 8. Plus 4 factorial 4 is going to be the same as 4 factorial 0. It's going to give us 1. X to the power of 0 is 1. 2 to the power of 4 is 16. Now I'm going to write the answer here. So this is going to give us x to the 4th power, 4 times 2, plus 8x to the 3rd power, plus 6 multiplied by 4 is 24, x to the 2nd power, plus 4 multiplied by 8 is going to be 32x plus 16. So let's recap on how we use the binomial theorem. The first thing we're going to do is to write this expression in binomial term here. And you break it up using the combinations. We're going to use the combinations here. And then you remember that your sum of your exponents must be the same as the sum of the exponent you're trying to expand. And then remember that with the value here, I don't want to use x, I don't want to say x because sometimes it's not x, it could be a or b. So on your binomial expression, the value on the left hand side is going to be decreasing in exponent, and the value on your right hand side is going to be increasing in exponent. It always starts at, for the value on the left hand side, you start at the highest, at the exponent, and you go all the way down to 0. And then the value on the right hand side, you start from 0 and then you increase all the way to the exponent. And once you understand this concept, you can solve any type of binomial. You can simplify any form or any type of binomial exponent expression.